I am Anil Kumar. In this video, we'll discuss trigonometric ratios for obtuse angles. We'll consider acute angles and their supplementary angles, so that will make obtuse angles. So I hope you understand what I'm trying to say here. We'll consider that we have an angle in quadrant 1, let us say like this, in quadrant 1, and then we'll consider 180 minus alpha, which will be an angle in quadrant 2, kind of like this, where if this angle is alpha, then the angle which we are talking about is 180 degrees minus alpha, right? So the point P, which was in quadrant 1, if I rotate it so that now the principal angle is 180 degrees minus alpha, then the point P dash will be in quadrant 2, right? So we had a point in quadrant 1 and now we got a point in quadrant 2. You will see that these 2 points are related, right? It's just a rotation. And any coordinate point here, which is kind of xy, will become minus xy in quadrant 2, right? As you can see from here. You can also form a triangle and then check the result. So in this particular figure, if I drop a perpendicular from P to x-axis, what do you get? You get 2 triangles whose sides are exactly same and therefore they are congruent. So what we notice here is that if you check from the origin, the triangle OP, let's call this Q, and this point as Q dash, is congruent to triangle OP dash Q, right? So you can now see that if I have an angle of 180 degrees minus alpha, we are talking about an angle which is greater than 90 degrees, since alpha is less than 90 degrees, right? So if we consider alpha to be an acute angle, that is between 0 to 90 degrees, in that case 180 degrees minus alpha will be an obtuse angle. That is, the angle theta, let's call this angle theta, will now be between 90 degrees to 180 degrees, correct? So if I call this angle as theta, in that case theta will be greater than 90 degrees and less than 180 degrees. We can say that it is in quadrant 2. So in this exercise, we will try to relate the acute angle with its supplementary. Supplementary angles, since 180 minus alpha, right? A straight line makes 180 degrees, so these 2 angles are supplementary angles. Since alpha plus theta is actually equals to 180 degrees, so that forms a supplementary angles. So I hope these terms are absolutely clear, and you can see for yourself that when we're talking about the same related acute angle in different quadrants, you will notice that this angle is still alpha, right? So in both the quadrants, the related acute angle is same. So note that related acute angle alpha is same in both quadrants. Is it clear? Correct? Both are same. The only thing is that the points which we consider now, their x coordinate value has changed to negative. Now that will make an effect. So how will cos alpha, tan alpha and sin alpha change if we relate them to 180 minus alpha? This is what we are going to check in our video. So to give you a heads up so that you can answer all these questions, you can see for yourself very clearly that since x value becomes negative, right? So the only transformation is that x changes to minus x, correct? Now that is going to affect tan and cosecant values, right? Since sine of theta is equal to y over r, where r is the length, sine does not change, right? Sine 180 minus alpha will be equals to sine alpha, since it is dependent on y, not on x. However, if you see cos theta is x over r. So in this case, cos 180 minus alpha will be equals to minus cos alpha, right? And similarly, tan theta, which is opposite value of y over x. Now x is in the denominator. X becomes negative. Therefore, tan 180 minus alpha is going to be minus tan alpha. Is that clear? And you can relate all of them with the diagram which I have made here, right? So let me just push this page a bit. So I hope that is absolutely clear. Now from here, let's take the following 10 multiple choice questions. The very first question is the true or false. You need to consider alpha between 0 to 90 degrees to answer these three questions. Question number 1. Cos alpha is equal to cos 180 minus alpha. Tan alpha is minus tan 180 minus alpha, and the value of sine 180 minus alpha is greater than equal to 0. Well, the first statement, as you know, is false. Cos alpha is actually equals to the negative value of cos 180 minus alpha, not the positive. In quadrant 2, only sine is positive, right? So only sine is positive here. Tan and cosine are negative. Tan alpha is minus tan 180 minus alpha. That is true. Tan is negative in quadrant 2. And sine is positive, and therefore the sine value will always be greater than or equal to 0, right? So that is also true. So I hope this is absolutely true. So what we learned here is that in quadrant 2, we have sine as positive. I mean, we can write this. Sine value is always positive. Cos value and tan values are negative in quadrant 2, correct? Okay, let's move on. And question number 4. If cos A equals to 3 over 5, then cos 180 degrees minus A is what? Question number 5. If for an obtuse angle A, sin A equals to 5 over 13, then cos A is what? Question 6. If tan A equals to minus 5 over 13, then measure of angle A is... I'd like you to pause the video, copy these questions, answer, and then look into my suggestions. The first one, we're talking about cos of 180 minus A. We are in quadrant 2, and we know in quadrant 2, cosine is negative, right? So we are expecting negative answer of this. So we get minus 3 over 5. Question 5. For an obtuse angle, sine value is positive. Let me sketch this and try to explain you. So let me sketch it here. So we're talking about an obtuse angle where sine is 5 over 13. So basically it's kind of like this. We can form a triangle like this, where the angle A is right there. Right? So this is 5, the other side is 13. You can use Pythagorean theorem to find the adjacent side, which is 12, correct? So that forms a triangle. So what is the cos value? We know in quadrant 2, only sine is positive, cosine will be negative. It is 12 over 13 negative value, correct? So that is your answer. Question 6. If tan A is minus 5 over 13, so in this particular case, we are saying tan A is, so the triangle is different, minus 5 over 13. So let me make this triangle separately now. One should not get confused. We're saying tan A is minus 5 over 13. So that basically means that the base here is 13, right? That is the angle A now we are talking about. So what is the measure of the angle? Now how to find such angles? To find these angles, we should actually find the related acute angle alpha. So we'll actually find the related acute angle alpha. Consider a triangle in quadrant 1 with this angle alpha, right? So we'll say, what is, we know tan A, so tan alpha is going to be positive, since in quadrant 1 all are positive, right? So it would be 5 over 13. So alpha is going to be equal to tan inverse 5 over 13. So let's use calculator to figure this out. So shift tan inverse 5 divided by 13 is equal to, it is equals to 21 degrees. Okay. Now if acute angles are same, so that is 21. So measure of angle A will be 180 degrees minus 21. Correct? So 180 minus 21 is 159. So that becomes the answer for question number 6. So I hope the steps involved are absolutely clear. If you directly use calculator, you'll get negative 21 as your answer, not the actual answer. Therefore, this is the method to be adopted. So note, the first step here is find related acute angles. We call this related acute angle. And then find the principal angle. Okay, let's move on. Now let's do question number 7 to 9. Consider theta to be between 0 to 180 degrees for question number 7 to 9. You may pause the video, copy questions, answer, and then look into my suggestions. If tan theta equals to minus 0.6, then cos 180 minus theta is what? So if you're given tan theta as a negative value, then we're talking about the point being in quadrant 2, right? So in quadrant 2, tan is negative. We're talking about this point. Angle theta is the obtuse angle. We need to find the related acute angle. 180 minus theta is that angle alpha. So if you find alpha, then cos 180 minus theta is going to be actually equals to cos alpha. So basically we have to find what cos alpha is. It has to be positive, correct? So that is the strategy. So let's use our calculator to find the angle alpha. So we can write this as tan alpha equals to positive value of 0.6. So alpha equals to tan inverse of 0.6. Let's use the calculator. Shift tan inverse 0.6 equals to 30.96. So we can write this as 31 degrees. So what is cos of 31 degrees? Let's figure this out. So I'll take cos of the angle which I have, which is equal to 0.857. So definitely a positive answer. 0.857 matches with A, 0.86. So I hope the steps are absolutely clear. Question number 8. If sine theta is 0.23, then cos theta is how much? Now remember, sine theta is positive. It could be in either quadrant 1 or in quadrant 2. So sine is positive in both the quadrant. So we are looking for two values, right? So we are looking for two values. Theta could be either one of these two. So we need plus and minus, so both are positive and negative values valid for us. So let's find the related acute angle and get the answer. So this basically cos theta is equals to, let's find first what is sine alpha. The related acute angle should also be 0.23. So alpha is equals to sine inverse of 0.23. Let's find this angle. It is shift sine inverse of 0.23 equals to 13.3 degrees. Now let's find cos of 13.3 degrees. So cos of 13.3 degrees is how much? So we'll do cos of the angle, which is our answer. It gives me 0.97. So 0.97 is the answer. Since we are looking for quadrant 1 as well as in quadrant 2, we have two answers. It matches with option B. I hope the steps are absolutely clear, right? So sine is positive in both these quadrants, and therefore we have two answers. There could be two values for theta. Question number 9. Which of the following cannot be true? So it is for theta which is between 0 to 180 degrees. So in these two quadrants, sine theta is negative. That cannot be true. Sine theta is always positive, right? So sine theta is greater than or equal to 0 when theta is between 0 to 180 degrees, right? So I hope that's absolutely clear. And of course, it is going to be less than equal to 1, right? So let's move on to the last question now, which is question number 10. Angle P is an angle in a triangle. Determine all measures of angle P to one decimal place. So we have two parts to this question. A, tan P is minus 1.75. B is sin P is 0.75. You can pause the video, answer this question, and then look into my suggestions. Angle P is an angle in a triangle. It really means that angle P has to be between 0 degrees to 180 degrees. I hope that's clear, right? Now, when we say tan value is negative, that means we are looking for quadrant 2, right? So tan P is somewhere in this. How do we find measure of angle P? We have to first find the related acute angle alpha. So alpha will be like here, right? That will be alpha. In quadrant 1, everything is positive. So tan alpha has to be 1.75. So alpha is tan inverse of 1.75. Correct? So let's find this angle first. So we have shift tan inverse 1.75 equals to 60.25. So we get alpha equals to 60.25. Now we have to round to one decimal place. So we can round this to, we'll do it later. We can find what angle P is. So the angle P is 180 degrees minus 60.25. And that is equal to, so 180 minus our answer, that gives us 119.74. Rounding to one decimal place, we get 119.7 degrees. Right? So that becomes the angle P. Now let's do part B. We are given angle P as equals to 0.75. Now for sine, as you have seen, when we say that the angle is from 0 to 180 degrees, sine could be positive for two different angles. So we could have angle P as this much or 180 minus that much, right? So there are two possible solutions. Let's again find angle alpha. So the strategy is always to find the related acute angle, which is always positive, right? So we get alpha as sine inverse of 0.75, which is equal to, we have shift sine inverse of 0.75, which is equals to 48.59, or you can say 48.6 degrees, right? So we have alpha as 48.6 degrees. So P, so the measurement of angle P will be equals to 48.6 and also 180 degrees minus 48.6 degrees. Since there are two answers for which you can get positive value of sine P, right? So you get 180 minus 48.6, and that gives you the answer is 131.4 degrees, right? So we have two solutions to this. So one is 131.4, the other one is 48.6. This we come to an end of our understanding on obtuse angle trigonometry. I hope you understand the concept how supplementary angles and the trigonometric ratios are related for these angles. Feel free to write your comment, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.